Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we'll be starting a brand new chapter, chapter 2 on number bases, okay? So the first subtopic that we'll be learning is learn to represent and explain numbers in various bases in terms of numerals, place values, digit values, and number values based on the collection process, okay? So from this table, we can see that base 2 to base 10 are the bases that we are going to learn today, okay? So the right hand side of this table are showing the digits involved for each of the bases. So for base 2, only 0 and 1 involved, okay? For example, 1 base 2 or 101 base 2, okay? Then for base 3, maybe 2 base 3 or 10 base 3, okay? So like this, you guys should understand better. So on and so forth for the case of base 4, base 5 until base 10, okay? So let us go through this example 1 together. Give 2 examples of numbers that represent numbers in base 2 up to base 10. Okay, after this example, you'll understand better about the table that we have just go through just now, okay? So for base 2, now we'll write 2 numbers, okay? So 10 base 2, 1001 base 2, okay? These are the 2 examples given. You guys can also write numbers like 111 base 2, 10101 base 2, okay? So for the case of base 3, 21 base 3, 1201 base 3, these are the 2 examples given. You guys can also write, for example, 2211 base 3, okay? As long as all the digits are made up of 0, 1 and 2 only for the case of base 3, okay? Then for the case of base 4, the digits involved are 0, 1, 2, 3, okay? So we can see that these are the 2 examples. For the case of base 5, the digits involved are 0, 1, 2, 3, 4, okay? So we can see that these are the 2 examples given, so on and so forth. And for the case of base 9, the digits involved are 0, 1, 2, 3, 4, 5, 6, 7, 8, okay? So we can see these are the examples, okay? So what are the place values involved in numbers in base 2 up to base 10? So regarding this table, I'll proceed to the next example to let you understand better about what are they talking about in the table just now, okay? Let's see this A. 6231 base 8, okay? So we'll put all this information in a table. So now it is base 8. And the power, we always starts from 0, okay? So 8 to the power 0, 8 to the power of 1, 8 to the power of 2, 8 to the power of 3. So let's say if the question asks, what is the place value for this underlined digit? We know that the place value is 8 to the power of 1, okay? Then let us proceed to B. 111101 base 2. Again, we transform it into a table. Now it's base 2, okay? So base 2, power 0. Always starts from power 0, okay? Then to the power 1, to the power 2, to the power 3, to the power 4, to the power 5, okay? Let's say now if the question asks what is the place value of this underlined value, so we know that the answer is 2 to the power of 4, okay? So how do you state the value of a particular digit in a number in various bases? Just now we learned about place value. Now is state the value. It is different, okay? So now let us refer to this example. 1010 base 2. So this is the underlying digit. The place value is 2 to the power of 1, and the digit value will be 1 times 2 to the power of 1, which is 2. Okay, then for this case 2012, for this underlying value, we know that the place value is 3 to the power of 3. Okay, because now it's base 3 and the power we always starts from 0. Okay, 3 to the power 1, 3 to the power 2, 3 to the power 3. And then now the digit value of the underlying digit will be 2 times 3 to the power 3, which is 54. Okay, then for this case 4432 base 5, the place value for this underlying digit will be 5 to the power of 3, and the digit value will be 4 times 5 to the power of 3, which is 500. Okay, and then 271 base 8, the place value of this underlying digit will be 8 power 2, and the digit value will be 2 times 8 power 2, which is 128. Okay, so now I believe that you guys are more familiar in how to differentiate the place value and the digit value. Okay, so let us go through this example 3 together. State the value of the underlying digit in each of the following numbers. So this underlying digit, we know the place value is 8 to the power of 2. Okay, so state the value. Now the question is asking about digit value. So 3 times 8 power 2 gives us 192. Then for B, this underlying digit 5, the place value is 9 power 3. So the digit value will be 5 times 9 over 3 gives us 3645. And then part C, 3501 base 6. The value of this underlying digit, first of all we'll find the place value. The place value is 6 to the power of 2. So the digit value is 5 times 6 to the power 2, which is 180. Then lastly 2134 base 5. So we want to find the digit value of this underlying digit. First of all, we have to find the place value. The place value is 5 to the power of 0. So the digit value is 4 times 5 to the power of 0 gives us 4. Anything to the power of 0 equals to 1. Okay, so now how do you state the numerical value of a number in various bases? Okay, so in short, now we have to learn to convert, let's say, a number in base 2 to a number in base 10. Okay, so let us look at the steps involved. Okay, so now the value involved is 11001 base 2. Okay, so we can see that all these are their respective place value, like what we have learned just now. Now is base 2, so always starts from power 0. So 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Okay, and then just now we also learned how to find the digit value, so we'll do so. 1 times 2 to the power 0 gives us 1. 0 times anything is 0. Again, 0 times anything is 0. 1 times 2 to the power 3 gives us 8. 1 times 2 to the power 4 gives us 16. And then we add up all these digit values. It will be a number in base 10. So these are the steps involved in how to convert a number in base 2 to base 10. Okay, let us look at another example. So part B, determine the value of a number in base 3. So even the question never say in base 3, right? We look at the place value, we'll know that this is a number in base 3. Okay, because 3 3 3 3 3 here. Okay, always starts from power 0. So 3 to the power 0, 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4. And then we also learn about digit value. This times this times this. Okay, so on and so forth. So we get all these values. and then when we add them up, we get 142 base 10. So this is 12021 base 3 in base 10. Okay, then now let's look at another example. So we can see that the place values 4 power 0, 4 power 1, 4 power 2, 4 power 3. So we know that this number is in base 4. 3021 base 4. Okay, so now we'll get the digit value. So this is the outcome, and then we add them up. We get 201 base 10. So 3021 base 4 in base 10 is actually 201. Okay, so now let's look at example 4. Determine the values of the following numbers. 340 base 5. These are the place values for each of the digit. And then 0 times 5 to power 0 is 0. 4 times 5 to power 1 is 20. 3 times 5 square is 75. Okay, and then we add them up, is 95. Okay, so now part B, 341 base 7. So again, we'll list down all the place values first, and then we get the digit value, and then we sum them up. So we get 341 base 7 in base 10 is 176. Okay, so same steps for part C. 1506 base 8. So all these are the place values, and we'll get the digit value and sum them up. So this is the answer, 838 base 10. Okay, wow, so today we have learned a lot of things. So remember to complete this self-practice 2.18 at home. If you guys are having a lot of difficulty in completing your homework, I have prepared an online course for you guys, a step-by-step guidance in helping you guys to complete your homework at home. Okay, so do not forget to subscribe to my YouTube channel, because coming next we'll be discussing on how to convert numbers from one base to another base. Okay, so I'll see you in the next video. Bye bye.